Hi, this is Math 1350, and we're going to be looking at section 1.7, which is going to be on combining functions. First part of this is really showing that the fact that how you can add, subtract, multiply, or divide functions, but also how the domain is handled, especially when you're dividing functions. So we can add functions, and when we do that, we're adding like terms. We can subtract functions, and when we do that, we're subtracting like terms. We can multiply them, and when we do that, we may have to FOIL or distribute or whatever multiplication process ends up resulting from it. For those three, we look at the domains of each function and the composite, or the intersection of the domain is the domain for the overall functions. So basically any restrictions in one function is a restriction for the whole overall function. And then we can divide functions, and when we do that, again, we look at the domains of each, but we also look at the divisor and when that may equal 0, because that also has to be restricted. Right, so let's say we have f of x is x squared plus x, and g of x is just x squared. Okay. Both of these have domains that are negative infinity to infinity, and so there's no strict restrictions. So if we want to do f of g, which is going to be also equal to g of f, so we're going to do both at the same time, it's just x squared plus x squared, which is going to be 2x squared plus x. If we're doing f minus g, which is not the same thing as g minus f, it's going to be x squared plus x minus x squared. X squared is, and I'm adding the 0, you get just x. If we do g minus f, then we're looking at x squared minus x plus x squared, which is going to be x squared minus x squared, which is a negative x. If we do g times f, which is going to be equal to f times g, then we have x squared plus x times x squared, which is going to be x to the 4th plus x cubed. All of these have no other restrictions, and because f of x and g of x have no restrictions, all of these have a domain that is negative infinity to infinity. Okay. Now we look at f of x divided by g of x. So we have x squared plus x over x squared. And so we can rewrite this as 1 plus 1 over x. Okay. And so the domain here, there's no restrictions in the original two, but there is a restriction here. X cannot be 0. So the domain here is from negative infinity to 0 and 0 to infinity. And then we look at g of x over f of x. We have x squared over x squared plus x. And so we can simplify this a little bit, factor out an x, and we get x plus 1. And so we have a domain that has two restrictions. So negative infinity to negative 1, negative 1 to 0, and 0 to infinity. Okay. And we can simplify that further x plus 1. Okay, x equaling 0 is still a domain issue, even though that x canceled out. Okay, so let's look at this next one. F of x equals square root of 25 minus x squared. G of x equals x plus 3. Alright, so g of x has a domain of all real numbers. 25 minus x squared, that has a domain that's going to be between 5 and -5. At -5 you'll get 25 minus 25, which is 0. And at 5 you get 25 minus 25, which is 0. Anything in between, like 0, you're going to have just a positive number. Anything outside of those regions is going to give you a negative underneath that square root. Alright, so f plus g is same as g plus f, which is going to be square root 25 minus x squared plus x plus 3. Not much you can do here to simplify. But your domain here is -5 to 5. Right, because that's the intersection of these two domains. Okay. Basically the restriction in f of x has to stay a restriction throughout the whole process. F minus g is square root of 25 minus x squared minus x plus 3, which is going to be square root of 25 minus x squared minus x minus 3. Doesn't really change anything. Domain is -5 to 5. G minus f is x plus 3 minus square root of 25 minus x squared. Not much you can do from there. Domain is still -5 to 5. F times g, same as g times f. X plus 3 times square root 25 minus x squared. Not much to simplify this, and your domain stays at -5 to 5. Alright, so now f divided by g, this is going to be square root of 25 minus x squared over x plus 3. Okay, we already have our restriction of -5 to 5 is the normal domain, but now we have to also restrict -3, because -3 will make g of x equal to 0. And so the domain here is from -5 to -3 union with -3 to 5. Okay, 5s and -5 are still included here. -3 is not included. And then g of x, x plus 3 in the top, square root 25 minus x squared. Okay, now your domain doesn't have it much different of a domain, except for the fact that 5 and -5 will cause this to be equal to 0. So we do have to take those out. So we just write it as -5 to 5, but put with parentheses indicating that -5 and 5 cannot go into this equation. Right. A composite function is when you take a function and you insert it into another function. So we write it f composite of g, and that means g goes into f. Okay, and so you can write it as f of g of x. So if f of x is 2x minus 3 and g of x is 4 minus x squared, then what we're going to do is we're going to put 4 minus x squared into our f of x. So this is going to be 2 times 4 minus x squared minus 3. And then we simplify. 8 minus 2x squared minus 3. And so 5 minus 2x squared. Okay. Now, domains for these, it's all real numbers. What we do is for the composite, we look at for the composite domain, we look at the number that you were inserting into the function, that domain, and any restrictions that apply. But then we also look at the overall function. And so for here, the domain's just going to be all real numbers, no restrictions on either case for the overall or for the input. The point of doing this is then we have a new function that we can find values for. So f of g of 2 is 5 minus 2 times 2 squared. And so 5 minus 2 times 4, which is going to be 5 minus 8, which is negative 3. This is the same thing as doing finding g of 2 being equal to 4 minus 2 squared, which is going to be equal to 0. And then finding f of 0, which is going to be 2 times 0 minus 3, which is going to be negative 3. Okay, so you can do it this way in a sense. One expression is not too bad, but if we have a lot of values we're plugging in to the new equation, it's nice to have just a new equation to do, one equation that we have to do it. F composite with g of x, or I should say g composite with f of x, where f goes in for g. So we have 2x minus 3, and we're putting that into 4 minus x squared. And so we want to FOIL this out. And so we get 4 minus, this way, 4x squared minus 6x, another 6x is minus 12x, and then plus 9. So 4 minus 4x squared plus 12x minus 9. So negative 4x squared plus 12x minus 5. Again, no domain restrictions here. All our numbers. If we look at g composite of f of 2, then we can find this by plugging in 2 for x in our new function. That should be an x here. And so we get, see, negative 4 times 4 is negative 16, plus 24 minus 5. And so we get 3. Notice that the functions we get when we do f composite with g and g composite with f of the same two functions are different. 5 minus 2x squared is not the same as negative 4x squared plus 12x minus 5. So which function goes into which is very important. And, we can also see that the values that evaluated at 2 are very different. Negative 3, and then this one's a positive 3. Most of the time that's going to be the case. We'll also look at when it's not, because it's kind of a special case, which is going to be the next section when we get into it. Alright, so f of x equals x over x plus 1, and g of x equals square root of x minus 4. So let's look at the domain. Here we have negative infinity to negative 1, and negative 1 to infinity. Basically, x can't be negative 1. And here we have, let's see, 4 to infinity, including 4. So g composite with f, So we'll have square root of x minus 4 over square root of x minus 4 plus 1. Right. Now our denominator, if the only way that you'll get 0 is if square root of x minus 4 ends up equaling -1, which won't happen. So that won't cause an issue. And then the numerator also, that won't be an issue with what values come out there. So your domain is just what g of x is, which is 4 to infinity. Okay. Notice, well, -1 isn't in the domain anyways, so we don't have to worry about that. But if it was and we plug it in, it may still be able to be plugged in depending on what function got plugged into it. So for example, let me do a separate example here. Let's say f of x is equal to x over x plus 1, but g of x is equal to square root of x plus 4. Okay, well, this domain is going to be -4 to infinity. If we plug that g of x into f of x, we'll still find f of g of x. We have square root of x plus 4 over square root of x plus 4 plus 1. Okay. Again, this square root cannot be -1, but it's a square root, and so you're not going to get a negative value out. Right, and so there's no way for it to be -1. So there's no other restrictions here. Your domain in this case is -4 to infinity. Okay, -1 is no longer a restriction. Right, if I plug -1 in, I get square root of 3 over square root of 3 plus 1. That's a real number. Okay, so that's why we only look at the input and we only look at the overall function. Alright, now going back up to the original one, we have square root of x minus 4 over square root of x minus 4 plus 1. And so we want to find g of 5, so it's square root of 5 minus 4 over square root of 5 minus 4 plus 1. So this is going to be square root of 1, which is 1, and that would be 2. Okay. In the next video, we'll look at inverses, which deal with composites that actually do equal each other when reversed. I'll see you then.